Assalamualaikum warahmatullahi wabarakatuh. The research is about analysis of effect electric field strength on safe distance below main substation Busbar 150 kV. The electric and magnetic field of the power system have become important problem. The reason for this is that the people discuss here issue that might be cause the electric and magnetic field. By following the International Commission on Non-Ionizing Radiation Protection ICNIRP of 2010, WHO 1989, for 50 Hz frequency, the threshold value of the electric field assessment is 5 kV per meter for the general public and 10 kV per meter for the working community. The intensity of the electric field is more than 10 kV per meter in most area of the substation. 500 kV exceed ICNIRP threshold value. Proposed research want to know the magnitude of the electric field strength below substation Busbar 150 kV. Want to know the field strength, the electric to safe distance below the substation Busbar 150 kV. Want to know the standard safe distance below substation Busbar 150 kV based on electric field strength. To know the standard time allowed to work below substation Busbar 150 kV. The method used is calculation and direct measurement. This research take 3 main substations: Ranca Kasumba Substation, Ranca Eke Substation, and Cikasungka Substation 150 kV. The parameter substation we see the 3 of main substation Ranca Kasumba, Ranca Eke, and Cikasungka have the same system voltage 150 kV. Have a system busbar, double busbar, have the conductor AAC looping 1 cross 1267 millimeter square, diameter conductor 46.3 millimeter, phase distance 3.75 meter, busbar distance with 6.5 meter, high busbar 8.75 meter. The lowest andongan, we see the figure 1. Laser distance meter, use the laser distance meter with the lowest andong, figure 2, the lowest andongan. We see the lowest andongan from 2 busbar 8.75 meter. The lowest andongan of the busbar conductor to the ground is needed as one of variable in the calculation of the electric field strength under the busbar substation. Measurements were made in each parcel of the busbar conductor with the laser distance meter as shown in figure 1. We see the figure 3. There are measurement point. The distance AB, FG, GH, HI, IG, and O is 162.5 centimeter. 2. The distance of BC, CD, DE, EF, GK, KL, LM, MNR 187.5 centimeter. In figure 3, it is explained where the point group is divided into 11 measurement points at 10 centimeter interval. For example, a group point consists of A0 to A23. Electric field measurement using Holiday EMF HI 3604. The result Ranca Kusumba substation with a measurement result and calculation result. We see there are two tables from measurement result and calculation result. There are two tables 2 for Ranca Eker substation, measurement result with calculation result. And there is the result Cikasungka substation with measurement result and calculation result. The analysis Ranca Kusumba substation. The measurement value of 10 kV per meter will exceed at the height of more than 1.3 meter from the ground surface, less than 6.2 meter from the Busbar conductor. The calculation value of 10 kV per meter will exceed an altitude of more than 1.3 meter from the ground level. They are less than 6.2 meter from the Busbar conductor. The minimum safety distance discussed in point 4.3, which is 8.6 meter, and the Busbar load of 7.5 meter, the distance 6.2 meter should not meet the safe distance. But based on the result measurement and calculation distance, more than 6.2 meter is still below the 10 kV per meter. If the ideal height and Indonesian mean 168 centimeter, the safe distance, the Busbar of the Ranca Kusumba substation is 7.88 meter. So, Busbar carried must rise 1.38 meter. Based on SNI 04 96950 to 003 about duration of exposure to the electric field strength 10 to 30 kV per meter can be calculated with the formula T less than 10 per A, where the A is electric field strength. So we can calculate the duration of exposure in hour. So we can use this example to calculate the measurement. From the measurement result, at 10 altitude of 1.7 meter from the ground surface, the maximum electric field strength value at point H70 is 15.33 kV per meter. So the duration is follow time less than 5.21 hour. From the result calculation, that at an altitude 1.7 meter to the ground surface, the maximum electric field strength value H17 is 10.44 kV per meter. The permit duration is follow time less than 7.59 hour. The same with Ranca Ekek substation. From the Ranca Ekek substation, the measurement value 10 kV per meter will exceed the altitude more than 1.3 meter from the ground level. So less than 6.2 from the Busbar conductor. We can see the calculation of 10 kV per meter will exceed the altitude of 1.7 meter from the ground. There are 5.6 meter from the Busbar conductor. Based on measurement, with the minimum safe distance discussed in it can the safe distance is below the Busbar. Ranca Ekek substation is 7.88 meter. So the Busbar carried mass rise 1.38 meter. So based on calculation with the minimum safe distance discussed, it can be the same. The safe distance is below Busbar of the Ranca Ekek substation is 7.48 meter. So with a 7 meter Busbar is still safe. From the measurement result, at an altitude of 1 meter from the ground surface, the maximum electric field strength at the point H17 is 13.89 kV per meter. Duration as a follow time less than 5.75 hour. From the calculation, the electric field strength is for point H11 is 10.11 kV per meter. Its permit duration is time less than 7.61 hour. With the Cikasungka substation, we can measure the value of 10 kV per meter will exceed at altitude 1.2 meter ground level. So the calculation value it can take the altitude of more than 1.3 meter to the ground level. Based on measurement with the minimum safety distance discussed, the idea have the calculation distance more than 6.3 meter, still below the 10 kV per meter. We see the safe distance is below the Busbar of the Cikasungka substation is 7.88 meter. So Busbar carried must rise 1.48 meter. So the safe distance is below Busbar. The Cikasungka substation is 7.88 meter. So Busbar carried must rise 1.39 meter. For Cikasungka substation, we can take the time less than 4.42 hours. From the result calculation, the permit duration with for Cikasungka substation more than long. The time take less than 7.46 hours. Conclusion: from the result of all tool testing, we can conclude from the result of measurement and calculation of the electric field strength, it is found that for the height of the test error measurement point, 2.3 meter from the ground surface, the maximum electric field strength is obtained between Busbar 1 and Busbar 2. The higher test measurement point, the greater the electric field strength, the closer the Busbar conductor, the greater the electric field strength. From the result of the measurement of the electric field strength is obtained that the shortest minimum safe distance is 7.88 meter in Ranca Kusumba main substation and Ranca Eke main substation, while the highest minimum safe distance is 7.98 meter Cikasungka main substation. From the calculation, the strength of the electric field, the shortest minimum safe distance 7.489 in Ranca Eke main station, while the highest minimum safe distance is 7.88 meter in Ranca Kusumba main substation and Cikasungka main substation. From the result of the measurement of the electric field strength obtained that the fastest duration electric field exposure was 5.42 hours for the Cikasungka substation, where the longest duration electric field exposure 5.75 hours at Ranca Eke main substation. From the calculation the electric field strength, it is obtained that the fastest duration of electric field exposure is 7.56 hours Cikasungka main substation, while the longest duration of the electric field exposure is 7.91 hours in Ranca Ekek main substation. Thank you. This reference from the research. Thank you very much.